Okay, so thank you for inviting me to give a talk and update on the Rubin Science Platform to the Science Collaboration Chairs today. I've probably prepared about a half an hour, 40-minute talk. I think probably the best thing is that you interrupt me as we go with questions. Rachel sent me some advanced questions on Monday. Thank you very much. I've tried to make sure that the discussion and the presentation of my talk covers those topics, but please feel free to interrupt if anything's not clear. I haven't covered them directly. All right. Okay. So I know you know what the Science Platform is, but I always like to start with a quick reminder of it. It is, we define the Rubin Science Platform as a set of integrated web applications and services deployed at data access centers through which the scientific community will access, visualize, subset, and perform next to the data analysis of the Rubin data products. The original vision for a science platform was laid out several years ago now. Sorry, very sensitive mouse. Several years ago now, in fact, Mario was on this call, was one of the original visionaries of this, together with David Chiardi and Gregory Dubois-Felsman. Gregory Dubois-Felsman still works on the science platform today. He is the product owner for the science platform within data management. He would have liked to have been here today, and he sends his regrets. He's on medical leave for a few weeks and would really like to have been here with us. So just a few of the things that have gone into consideration here. You can see some of the high-level points that we thought about when designing the science platform. Clearly enabling petascale analysis of LSST data, enabling exploratory analysis via web browsing and visualization. So not needing to know in advance what is the schema of the catalogs and how do you find images, but having something very exploratory and interactive to enable discovery of the data, just to go and be able to have a look. Obviously, scientists are going to want to run their analysis on the data products and create derived data products. We call these user-generated data products. So the science platform supports the ability for users to use the services and the data products from LSST to create their own data products for doing science. Integration with extant archives via IVOA. IVOA is a driving principle for the design of the science platform. We adopt what's called an IVO first strategy, and where possible, we adopt and use the protocols of the IVOA. This allows for easy interoperability with other services that are IVOA compliant, with archives at other data centers. And I will give you some examples of how the IVOA services that we already have deployed on the science platform today are in use as part of the data previews. A collaborative working environment was also a strong driver. I mean, people are going to want to come together dynamically in teams to work on a particular topic, perhaps around a paper. So you want to have a science platform that supports things in terms of shared workspaces, shared access to derivatives and analyses by teams of people, and to create these teams dynamically to work on different analyses. The science platform itself doesn't provide computational resources. I think this was a question from Rachel. Will the science platform provide GPU? I'll come to that GPU topic a little bit further in the talk, but the science platform actually doesn't provide itself resources. The science platform runs at data centers, and the data centers have resources, and those resources are made available via the science platform to the users to perform analysis, to access data. So the resources store the images, they store the catalogs, and the science platform is the service that sits on top of that and provides access to the users. So the science platform is what's called a three-aspect design. There are three aspects: the portal, the notebooks, and the web APIs. The portal aspect, which is in production today, it is the Firefly portal from Caltech, from IPAC. It enables exploratory analysis and visualization of the archive. So I'll show you an example in a minute where you can connect and you can just walk about, meander around, and have a look and say, oh, what's here? I don't know anything about these catalogs, what's there? So that's what it's meant to enable. The notebook aspect is designed and is focused on in-depth next to the data analysis. So these are Jupyter notebooks that support Python, that you can open up a Jupyter notebook, that it provides you access to the backend resources, compute facilities, compute storage, the data products, and you can work with the data products to do additional computation in Python. And the API aspect provides remote access to the LSST archive via the virtual observatory, the VO interfaces that I've just mentioned. Just something to note is that the API access, whilst it will expose the services and the data products of the science platform to you if you're external, these services are also used internally by the notebook and the portal aspect to move data and to provide access between the notebook and the portal aspect as well. So it's not that we have one internal set of methods for moving data around and accessing data, and the different user-facing ones, they are all the VO services, and they're all the same services. So I think, Rachel, you asked, you said that there was an API aspect in the original design. Do we still plan to provide this? Yes, we do. And I will show you what's in production today, and I will give you a little taster of what's about to come in DP0.2. So as I've just said, these three aspects here all sit on the back of a lot of back-end services like software tools, user computing, data files, databases, and data releases. Okay, so let's look at what we have. This is an example of the portal aspect. It enables data discovery. Here, I show you a snapshot from Data Preview 2. This is this was a query executed that has retrieved data in this is a cone search. You can see all the data points and the source detections. This gives you a catalog of all the entries. And then it's very easy to interactively create a color magnitude diagram. So this is very interactive, and you can play around with it, and it allows you to explore the data. It's focused very much on exploratory analysis and visualization of images. And there's a link here to some additional documentation. Here I show you exactly what we have on the Science platform today. So if you log into the portal aspect, you will see this page here. I've chosen the single table query type. You can see here, it says select tap service, the Rubin Science Platform. This is an example of what I just said of the API services, the tap service also being used internally to query the data products by the portal aspect and by the notebook aspect. So here, if you look at, if I want to do a single query type, here it shows me the tables. This is a pull down list. So here we have the DP0.1 catalogs from desk. This is just the object catalog. And here I can, through a GUI, I can just put in the parameters for a simple cone search. So I'm doing a cone search. I've got a set of coordinates. Here I have a radius. That's my center point, the radius. And here I specify exactly the columns that I would like to retrieve. So you can go through, this allows you to search. And this also allows you to put constraints on here. Like, I want a G magnitude of less than 24. And I want to set some limits on the errors. And then I want an extendedness value of 0, for example. And you see also that there's description and documentation of what exactly all of these parameters as part of the schema are. So you can populate and edit the ADQL. And if I were to press this button, then you get this. If you go over here to the edit ADQL, if you don't know ADQL very well, you can use this interface, and you can see over here, it will generate an ADQL query for you. And when you go into the ADQL view, you can also go to the schema browser, and this allows you to browse through the different catalogs and information in them that's there.
So Leanne, if I can ask a quick question. Mm-hmm. You showed on the previous plot a scatter diagram. I guess it was a color magnitude diagram. So how much flexibility do you have at the portal level of what kind of plots you might make of the objects?
Quite a lot. Yeah, I mean, I've just shown you an example of an output, but once I got my data set, the data set actually came from here. It brought this up in a standard default layout. This is in fact the result of that. Okay. And then you can go in here, see it says try view, image table, image XY. There are different types of plots that you can come up with. And then once you get into these and you go drill down to these little icons here, you can see here that I've put in 2 columns, and I've done a mag R minus mag I. So we've got, and then I've put G. So you can do all sorts of manipulations. It's quite powerful. And I know that IPAC are continuing to invest in the portal. It's going to be used for the SphereX mission as well as LSST. So they are investing in continuing to build on this tool.
So Gordon has asked a question. Yeah. Gordon, do you want to
know how ADQL differs from SQL?
ADQL is the astronomical data query language. I usually say it's built on top of SQL. It is basically SQL with additional functionality oriented towards astronomy and astronomical use of SQL. So let me go back and show you. If you can read this, that is SQL. I think that there is SQL, but if I were to add in, any of these examples here, polygon, box, circle, distance, to do a cone search, that's actually not the cone search from here. These are additions on top of it, oriented towards a lot of things that we do in astronomy. So you can use standard SQL in here, and you can use the additional functionality for astronomical queries, just easier at the user level.
Thank you.
Michael, is that another hand or is that an old hand?
Old hand. I always forget. Sorry.
All right, let's move on to the notebook aspect. So here I show you an example of how to do next to the data analysis in Python in Jupyter Notebooks on the Science platform. And I've taken a snapshot here of a notebook that I wrote for the DP0.1 tutorials. This is called Intermediate Tap Queries, and it shows you how to execute a tap query in ADQL and in the notebook to retrieve data and then to show plots and build up interactive plots. And so here you can see that I'm using I'm using the AstroPy sky coordinate object to define positions and to define a radius. Then I just write an SQL query that's in here by passing the coordinates. To answer Gordon before, this circle here, this command, this is part of ADQL. So standard SQL won't support a circle search with an ICRS coordinate reference system, for example. So then I execute this, I get the results back, and in another view here, I can pull up an image. This here shows you a DC2 image that I've pulled up, that I've done some manipulations on. I've done some stretching with it. And this is an example of an interactive plot where I've overlaid other information from the catalog in the objects that are plotted. This here I'm using bokeh and hollow views to plot. And so as I move around these, I can hover over the different objects and get information about them. So this is in pixel coordinates here. And the Z is the intensity. You can lay a WCS on top of this and transform this into sky coordinates. You can do all sorts of things with data you retrieve from a catalog and have as part of annotations on an image so that you can get information about images and interact with them. So this is the notebook aspect is a very powerful environment to do a lot of manipulations with images and data using all your favorite Python tools. You can do machine learning work if you want. The notebook aspect, the user environments that you get when you log on to the notebook aspect come with the LSST Science pipelines installed together with AstroPy and a lot of other popular tools that users use. Again, subsetting with forms and ADQL is all supported. And as said before, this sits on top of resources at the data center where this is running. Here's another example from DP0.2. Jeff Carlin wrote this notebook. This shows how we can, the portal aspect, the Firefly visualization system can interact with the notebook. Here, Jeff has retrieved a co-added image from the DESK DC2 dataset by passing a track number, a patch, and a band. He has retrieved that calyx using the butler. He has got some information about the forced sources from the reference table. So he's got not just the image, but the detections that came out of the science pipelines. And then using AFW with Firefly as a backend, as opposed to say Matplotlib or bokeh or another visualization tool. This is the visualization you'll notice. In fact, Michael, you just asked before, what sort of power do you have with to make images? This is the same visualization tool that showed that image in the portal. Now we're using that to display images we get back from the notebook. And this is the image you can see here in the background. And Jeff has chosen to plot just those sources in a 1000 by 1000 pixel value area. Here he has plotted all the detections with, I think it's blue are the stars and orange are the galaxies, I think, based on extendedness.
Leanne, I have a couple of questions, if that's okay.
Oh, go ahead.
Do we have access to our own environments, such as Condor, and Brew pip installation, so that we can create an environment and preserve it over time and then turn it on and off?
You mean create
specific
different environments? Create different Condor environments in your user space. You mean like virtual environments?
Yeah, to have specific versions of software.
That's not supported at the moment. You can't do that right now. Whether it's going to be and how that's going to be, I'm not sure.
Okay, thank you. And then when you render the images, is there any concerns about latency and how it may scale with the number of active users? If they all use the very nice image visualization software.
Yeah, I mean, clearly the backend resources have to support the number of users that we will have. And so we have a pretty good idea of the number of users we're expecting. We're basing our estimates around a user community of 7,500 to 10,000 people. And so we will be provisioned appropriately. And a lot of the experience of DP0.1 and .2 is to prepare us for this. So as you probably know, we started out with only 300 delegates, and we wanted to understand how our resource provisioning would work, how people will actually use these resources. And so we're scaling up slowly through the next 2 years as we come towards operation to make sure that we have understood how people use the science platform, not just through, in principle or in use cases or based on other archives, but seeing how people are starting to work with these simulated data sets and eventually the commissioning data. But I'll come to how additional resources could be provisioned a little bit later.
Thanks.
Okay, this shows you another example of what you can do in the notebooks. I'm a huge fan of the HoloViz environment for plotting, the bokeh HoloViews data shader panel visualization system. They're very powerful, and this shows you here an example of 2 linked plots. Keith Bechtel provided this in the context of Stat Club. He took a data set from the Dark Energy Survey's data release 1, and here is a data set. Here is this whole data set where he has a spatial distribution plot here. And when you take the information out, you can annotate the plot so that when you hover over the points, you can get information about the data itself. And so this enables a sort of a form of drill down. This is all fully configurable. And so if we looked at this plot and we found a giant great hole, or we found a strange distribution of objects in a certain area, then you can hover over them, find out what they are, and then easily go and drill down onto objects that might look like anomalies and find out what's going on. And then you can also link these plots by taking the same data set, but showing a different representation. So here we have a spatial plot, and here we have a color, CMD, a color magnitude diagram. And you can see the points that I hover over here, these three are shown here, and that they come up. So you can show the linking. If you see anomalous points here, you can say, well, what do they look like on the color magnitude diagram? And then you can come up with all the different representations. So these are very powerful tools, and this is all deployed on the science platform. You can use it, and these are in use for DP0.2.
Yeah, I got a quick question for you. You talk a lot about bokeh. What happens if I want to use Seaborn or some other library for plotting? Is that allowable, or do I have to
yeah, it's allowable.
use bokeh?
Yeah, absolutely. You don't have to use bokeh at all. I'm a huge fan of it. Very few people actually do use it in my experience. Most people still stick with Matplotlib.
Does that mean I can install that, or is that something I have to request?
I'm pretty sure that Seaborn is part of the standard installation. I don't use it a lot myself, but I'm fairly sure I've seen it, and I can do a test after this talk if you like and let you know. I can try and just do a Seaborn based example if you want, but I'm pretty sure, first of all, I'm pretty sure it is installed. Secondly, to answer the more general question, can you install your own packages? Yes, you can. So if it weren't, you'd be able to install it and use it. Okay, now the API aspect, the final one. This provides us not only cohesion between the different aspects of the science platform, but it provides integration with external tools. As I said before, we have a VO-first strategy. So we use TAP for catalogs and SIA version 2 for images. For the backend platform services, databases, images, files, these will all be exposed through machine accessible web APIs as part of this API service. We have a TAP service for catalogs currently in production as part of DP0.1 and in 2. We will be also providing an OBS TAP service and an image cutout service as part of DP0.2 that's coming up, that will allow you to access metadata about images, retrieve images, and create on-the-fly image cutouts. This shows you an example of integration with Tomcat. Many people use Topcat, sorry, not Tomcat. This is Tomcat using accessing catalogs using VO protocols and creating plots. You will be able to do this with LSST data. I will show you this right now. Okay, so here's an example of querying external archives. You can do you can go both directions with the science platform. I can be on the science platform and be running an analysis and say, oh, wow, I'd love to get the Gaia positions or the Gaia information for this data set. So here, this is from the portal aspect. Many TAP services are already exposed through the portal aspect. So if you log on and you do this pull down, here is the Gaia one, you've got CADC, the URSA, there's the science platform, that's ours. Many of them, sorry, the Exoplanet Archive is there. So all these services around the world, if they conform to the VO standards and they expose their TAPs, their services, their VO services conforming to the standard APIs, all other archives will pick them up and they'll provide you with a pull down list for them. So here I go and I choose Gaia. So it pulls up immediately the Gaia schema. Here I have Gaia data release 1, Gaia data release 2, and then you have the single solar system object, sorry, the Cepheids, solar system object orbits, the Gaia source table. And I can then execute an ADQL query on this data at the Gaia archive in Spain. Here is an example of my ADQL query where I'm doing a cone search, I think, here, around a point, the angular separation. There's my circle, there's the point it's about. I retrieve the mean magnitude in the Gaia G band, that's the very broad band, Gaia very broad band with parallax not null. So I put some criteria on there, I order by angular separation. And this brings me back, this is the result you get in the portal aspect. And so here is all the catalog data that's come from my query. But if you look here now in the image, you see that it plots the data on the Gaia image and a Gaia background image. So it also pulls up this image this is sort of an OBSTAP service, and provides you with this nice background image Gaia to overlay the data set that I have retrieved. Oops. And then over here, I can create a whole lot of different plots from that. So here it's just a spatial distribution of the data I've retrieved. This is my data set here in case you didn't see it. So I just put a very small radius in, and that is that, and it's just superimposed on the Gaia density map. So that's executing queries of other archives from the Science Platform. I could then take that data and then I could merge them, or I could not merge them, but I could use them together with my LSST data to do an analysis. This works the other way around as well. Here I'm using TopCat. So I just installed TopCat on my computer last night. Opened up TopCat. So you go to TopCat's table access service. You have to type in our URL. It won't come up in the pull down menu because we're not exposing it. LSST data is not going to be world public. So there will be access tokens. So it doesn't come up here because first of all, we're limiting access at the moment to our early services in case we kill them. We don't want to expose our TAP service and our data preview 0.1 service to the whole world. That will crash it. That will go, we're trying to scale this up. And also eventually we're going to need to have authentication because LSST data will not be world public. So when I pull up this TAP service here and I click use service, I get asked for authentication. You generate your security token by going to the Science Platform web page itself. You log on as yourself. If you are an LSST user or data rights holder, you'll be able to log on. And then once you've logged on, you generate a security token, which you then take back up here and you put into this password field. And then that gives you access to the data on the Science Platform, exposed by the Science Platform from an external tool like TopCat. And so the result that comes back is this. I will then get in the table access query window of TopCat, this will then bring up the DC2 catalogs because I'm now authenticated. It shows here the TAP schema. Then I can put in my ADQL query, the same ones I had before. And then using TopCat, I can make a color magnitude diagram. And if you're more familiar with a tool like TopCat, you can then go and use TopCat to access the data on the Science Platform. I did this last night, so it works. It's in production at the moment. You will be limited though in the data that you can retrieve over this in this manner by the data limits that are restricted by that are put in place over the VO services. So what this means is you won't be able to retrieve the entire LSST object catalog over TAP and then do cross-matching with another catalog on your local computer, for example. That sort of large-scale processing is better suited to another way of processing the data. All right, so in terms of software tools, someone asked about software tools, but we're probably going to get a bit short on time here, so I might try and speed up a bit. So a lot of pre-installed software tools will come as part of the Science Platform, including the LSST Science Pipelines distributions. For those of you who've logged on already, you'll see a window like this. It gives you the weekly, so here you have the major releases, release 23 of the Science Pipelines, but you also have, the weekly releases, the daily releases, and a lot older. We continue to expose many of the older releases and versions of the Science Pipelines to people to work with. You get to choose between 1, 2, or 4 CPUs at the moment in terms of the server. We don't, this is all we're exposing right now. This gives you an idea of the resources we have at the moment to expose to users. And then when you start up your notebooks, you can choose a preferred kernel. Here we provide an LSST kernel, which has the science pipelines already installed, already set up and configured in order for you to just start typing Python code and use the LSST science pipelines as part of it. The programming languages supported are Python and C++. These are the languages that science pipelines are written in. These are the only two we support at the moment. Rachel, you asked about IDL. We don't currently support IDL on the science platform. And I don't think we ever will. And as I've already said before, users can install their own tools as well. Okay, I'm going to move on to user computing and batch and capacity. If there's any sort of questions more about the science platform and its functionality, based on what I've just said, let me know. It might be best to ask them now.
Leanne, I wanted to ask about visualizations. You showed lovely things, but they're not relevant to anything I do. So I wanted to ask is there plans to be able to do solar system visualizations, like visualize an orbit overplotted on the LSST footprint, or like if I can pull up an observation and it would tell me from the MPC orbit, because it's going to be stored in a table, that you would have it up on, within the image and tell me this is where the position is. Is that stuff that will be visualized for solar system?
Those
the solar system data products?
Yeah, I think that with the solar system data products that we will expose, once we've computed them and served them, and that has orbit information, plus with the MPC, if the MPC exposes its catalogs and information over TAP, using standard visualization tools, you should be able to do that sort of thing. I don't know that you need a particular visualization tool, but you need access to the data products and the computer.
So I have to write it. Rubin's not providing any of that.
You mean something that says plot orbit, and then it goes
well,
to
you import a Gaia and it plotted Gaia and it put my data points up, right? No one has to write that. So
okay. So
right so if I'm like, I have an orbit, be like, well, find me the LSST image and put the LSST image up and plot over it.
Okay, so
I guess that's what I'm asking. Is there any specific visualizations that are planned for solar system?
No. Okay,
right.
so just about the Gaia one, what it did was just plotted the right ascension versus the declination. I could have queried any data set at any archive and it would have given that same plot. And then I went and did the manipulations to make a color magnitude diagram out of the Gaia data that I retrieved, knowing knowing the schema for the catalog and knowing what the columns were called and how to get the colors. So it didn't automatically do that. We don't plan to provide those sorts of tools for specific science collaborations. And I think, maybe Mario would like to say something here. That was part of the focus of the Link Day workshop a week or two ago, was what sort of additional tools are needed to help the science collaborations make best use of the data products and the services from the science platform. So something like that sounds like it's specific to solar system and would be something that would be very much in scope for the Link project, but I might let Mario respond to that. Muted. You're muted, Mario.
You're muted.
I think that the challenge that Meg has been referring to is that the solar system catalogs are not catalogs of point sources in predefined position and time, but they're orbits and that have to be computed. And so the actual position has to be computed for every place in the LSST catalog, which is kind of non-trivial. So the ordinary TAP queries wouldn't work here. I don't know what the answer is, Meg. I don't quite understand how much of this could be done externally versus how much it would have to be done internally to really scale for, let's say, the entire catalog. But I think it's something that we can look into and, ultimately maybe build as a community product, or maybe have as one of the improvements in long-term in operations for Rubin. But I don't really have a good answer for you right now.
Thanks. I think one of our struggles is that most of us are not using or trying out the RSP because it doesn't have solar system objects. So I know very few of my science collaboration members have joined because they're like, well, what's the point? I'm going to be working. I have limited time and I could work on writing this other thing we need versus joining RSP. So I think we're right now struggling because we don't know what's in there because of that. So it might, I don't know if there's a good solution to that, but it is something that we might not quite know what we have to do for RSP as a community to be ready for that.
Yeah, no, Meg, I mean, we're very well aware of the fact that the DESC DC2 data set does not benefit the solar system science collaboration in any way. And we're aware of this and we're looking to do something about it. Let's just leave it. I'll leave it there for now. But I mean, I'd like us to try to host some solar system relevant data on the science platform so that more people from the solar system can get involved.
Great, thanks.
I don't pile on to this, but I see Gordon mentioned saying for AGN, and there are, just in general, time variability is not really well served by DP0, and I know that it's coming up in future surveys, but I have one question that, so I understand the workflow very well for the examples that you gave, but they're mostly catalog based. Mm-hmm. And I think the question that Gordon, Graham also had in the chat is similar to what I'm asking. Do we also have access to single visit pixel data? And how do we get access to the alert data if we want to use the alert, or more relevantly, perhaps, if we want to use catalog data and alert-based data jointly for time domain science?
Okay. So will you have access to the pixel level data? You will. When you get the images, you'll have the full image and you'll have the information in the image. You can get the images. And the next question, the next alerts, right? So if you want the alert, when I say alert, I mean the alert packet. The best place to go is a community broker. But the information in the alert packet is also stored in the prompt products database. Plus additional information. So the information in the alert packet goes out. The alert packet is created within 60 seconds of shutter close, and then the alert packet goes out to brokers and they do additional analysis, and then they work on doing follow-up with other networks. And that's all outside of the scope of LSP, of LSST and the science pipeline. The same information in the alert packet goes into the prompt products database, and within 24 hours, that prompt products database is updated for every detection in a difference image with additional information that's come from the nightly, from the daily processing, the 24-hour processing, which we can't compute within 60 seconds. So we don't need it in order to enable follow-up, but we also don't have the budget to compute it within 60 seconds and put it all into the alert packet. So the best way to work with data that's in the alert packets is to query the prompt products database on the science platform.
And what about the information that the brokers augment to the alerts? Is there a plan to facilitate easy access to that information?
So that's very much out of our scope, what the brokers do. And the brokers are all going to do different things. Each of these brokers are independent brokers, and they're going to be doing their own thing. If they expose this information over, say, a TAP service, you could query it, for example, and get that information. I'm just thinking out loud here. That's what I do.
That's what I was thinking, that we need to.
Yeah.
I was thinking it's important that we communicate that to the brokers, that it would be critical for them to make it TAP accessible so that it can be integrated back. Chuck has his hand up.
Yeah, I just wanted to toss in one little piece of maybe trivial information here. The engineering data that we collect during the survey is also queryable through the RSP. So if you're trying to correlate systematics that you see in the data with something technical, that is available to you as well. I just wanted to put that into the conversation. That's it.
Thanks, Chuck. Okay, we're going to run short on time. So let me just move on a bit. So in terms of user computing capacity, right? So we've talked about what's going to be served up and what you can do, but obviously when users do analyses, that's going to require resources. The original, the requirements as they're originally written down quite a number of years ago envisaged 10% of the total LSST data processing capacity that includes computing and storage for scientific analyses at data centers. This is fairly ill-defined and has been a topic of a lot of discussion. We know that 10% will not be enough to satisfy even the need. Well, even the whole 10% would not be enough to satisfy the needs of the dark energy science collaboration in their analyses. And we assume for this 10% that DESC has access to DOE provided resources elsewhere. So the focus with DESC will be, given that they have NERSC and they have storage and compute at NERSC, The focus we'll take with the desk is to make sure they have the data products and the images and they can use their own services. So this 10%, we're thinking more about focusing on the needs of the smaller needs of the other science collaborations and the rest of the community to provide access to data and computing resources. I probably don't need to go through this, and I want to skip over it. This is just if you want to have a look at some of the science drivers that we're thinking of in terms of user-generated data products. I have some here, and then I have, this is the tech note where we have our use cases and science requirements on user batch. Please take a look at it and send me feedback if you'd like to. So user batch services are the user-facing computational capabilities that are used to provide resources to the community to do their user computing. In scope, we have running in bulk over both image and catalog data, providing a software framework to facilitate both catalog and image-based user computation. So this needs to support systematic runs over collections of data and preservation of provenance. Provenance is a difficult topic. Rerunning standard computations from the pipelines. So for example, a case here is that you might want to re-estimate the background and subtract a different background, but you want to run using exactly the same version of the science pipeline, so just with a different background estimation. And to support sort of more free-form user jobs. So, sort of less well-defined. Whatever mechanism we do put in place, there will be quotas. So these can be modified per user, but there'll be some sort of birthright quota that comes out that people are given. Don't ask me what it will be at the moment. We don't know. We haven't put a number on it. I certainly hope it will be sort of equivalent to what you might expect at other data centers. And these can be associated with user-defined groups. So this is what I mentioned before about collaborative work, that this can support ad hoc collaborations or science collaborations, as well, more defined science collaborations. Resources will not be infinite, so there's some form of time allocation committee is foreseen for user batch in operations. I think I've covered most of this about supporting collaborative work and sharing data sets, backend services. So the backend services that will be exposed to the science platform include the prompt and data release catalog data products. This is what I mentioned before about using the prompt information. If it's in the alert packet, it's also in the prompt database, so you can work with that. User databases, so for user-generated products, these will be stored in relational databases. Everything will be accessible via ADQL. Per user file space allocation will be provided with a birthright. Users will be able to upload code and data sets, transform data sets within the allocation they've been assigned. There will be CPU provided at data facilities, and any analysis performed via the aspects will be served by a common shared computing cluster. So it's not that the portal has resources and the notebook aspect has resources. There's one common computing cluster sitting behind this. And you can launch jobs through APIs exposed through the notebook and web aspects. I've got some examples of using TAP, asynchronous TAP to launch jobs to query catalogs, and through the batch services as well. If you use a batch for large scale processing, you'll also be able to launch jobs through these APIs. We don't have a lot of time, so I might skip over this. Do people want to hear about the data previews? I think so, yes.
What are our options? The data previews or?
We've got data previews, the data facilities, the hybrid model working in the cloud. Yeah, that's mostly what I've got left. Data previews plus the data facilities and the hybrid model. I think
anybody have?
I'll just keep going. I don't see any.
Yeah.
Yeah. Okay. So as most of you probably know already, the Rubin Observatory Operations is preparing the community and itself for operations by providing data for doing science through a series of data previews. So this is to avoid, with data release 1, we just put the science platform out there and nobody's ever used it, nobody's ever tried it. We're scaling up both ourselves and the community to be ready to exploit science when it comes with the first data release. We have 3 planned data previews between June last year, and the start of LSST data taking. Or actually, DP0.2 will be released as data taking has started, but before data release 1. Data Preview 0 is currently in operation at the moment, and it's based on the desk simulated dataset DC2. The desk very kindly allowed us to use this dataset to support our data previews. We've split this into two, DP0.1, in which we simply served the desk-produced data products. These were produced with version 19 of the science pipeline several years ago. And in DP0.2, in which we will serve reprocessed, the reprocessed DC2 data sets. So taking the most recent version 23 of the science pipelines and serving those data products out. We opened this up to 300 delegates, AKA users, in June of 2021. And that has been very successful. Many people have been working with the desk data products, and it's been very informative. There is a planning document here if you'd like to have a look at any of the details as to how we're going to move through these data previews. We're going to ramp up not just the resources, the science platform, the number of users, but also the data products served. We will not serve all data products in the early data preview. So DP0.1 served the raw images, the data release processing processed visit images and catalogs, co-edited images, and object and forced source catalogs. And that was all. That was what desk produced, and we chose just to serve those. In DP0.2, which is coming up in June this year, we will also be serving difference images and sources detected in difference image analysis, as well as the forced source catalogs, including outputs from difference image analysis. And this is the one that's, I think, really key to supporting the time domain. I forget someone before asked about time domain science and the fact that DP0.1 wasn't really very supportive for this. We will have the forced source catalogs available, and this will enable much more time domain science as part of DP0.2. DP1 is going to be based on data taken with ComCam, on-sky data. So this will be data with the LSST commissioning camera. The commissioning camera, just to remind you, is one raft of the whole camera. And here we envisage serving all the data products except live alerts and solar system catalogs. We will serve what are called canned alerts. This will be, these are alerts that we will have produced, but not within the 60-second latency. So it'll be with some delay and some latency that is not 60 seconds. For DP0.2, this is data that will be taken with the LSST camera on sky. So this is the science camera. When we put it onto the telescope and start running with the system integration and test data, provided it's in focus and it's good enough, plus all the data collected during the science verification surveys. And again, everything but solar system catalogs will be provided. We have to have ramped up producing live alerts by DP2 in order to support the start of operations. And data release 1, which is based on the first 6 months of LSST data, will include all of these data products. The schedule here is very much dependent upon the construction schedule. So data release 1 is tied to 6 months of LSST data taking, and the range of dates that are planned here, July to September for DP1. We know that DP0.2 is coming out in June 2022. We're on track for that. Nobody's concerned about this. And DP0.1 did come out in June 2021. So July to September 2023, April to September 2024. This just reflects the fact that the construction schedule is still, undergoing changes for many reasons.
Leanne, I just wanted to ask a question about that schedule. So if we say there's a June 2024 start date, then you've got a little bit of time when there's alerts and other things. Is there plans in terms of how the sort of front-face community sort of liaisons, including the data management liaisons, the CET, et cetera, how they're going to strategize for that in terms of ramping up the community? Like, is there plan to be more workshops or a hack week or something? Because that's when everybody kind of gets the real deal.
Yeah. So you've been working with alerts and alert production.
I mean, everything, right? It's everything from, it's ComCam data, right? That's real sky. It's not simulated anymore. So, solar system actually has stuff in there because for a while we don't have anything. Like there will be some alerts, right? So is there has there been a strategy of how the community is going to get supported in that? Because I could see that being a huge time where we all dive in at once, for people that were maybe not paying attention to the data preview, the other data previews, for example, or
okay, so
doesn't have the things they need.
Just
DP1, yeah.
Yeah, I think you're
so I'm saying, yes. So when DP1's released, is there like a strategy or a plan of how you'll engage with the community, because I think there'll be a large number of people diving in instantaneously, right? So like, if that's gonna be released, having like hack weeks, right, might be helpful, where you could bring people out and have those people that have the expertise to help guide, right, be there for a week or.
Yeah. Okay. No, that's a good point. I mean, the reason that we're trying to get people involved early and ramp up early is to slowly get more and more members of the community familiar with the services and the data products, so that they can help the rest of the community as well. And I realize solar system is not well served by this at the moment, but I hope we can provide a solution to that. But for the rest of the community, the idea is to seed knowledge and expertise within the community, so that people can go back to their institutions, their science collaborations, and take that knowledge with them. This is why we call the delegates, not users, because they dedicate a certain amount of their time and then go back and help their institution. So we're looking at this more distributed model of trying to build up knowledge and expertise. The community platform is where we're trying to get people to ask questions and to facilitate discussions. You mentioned hack weeks and things like that. I think that we will start to organize more of those sorts of things. It is within our community engagement model to organize those sorts of sessions, workshops, hack weeks, where people can come to. We don't have concrete plans yet, but it's certainly part of our thinking.
So we only have 7 minutes left. Chuck has his hand up, and we do have Melissa from the community engagement team, so maybe we should organize a chat with them in the near future. I'll probably leave that task to the next coordinator. Chuck, did you have anything to briefly add to this?
Fed, I was going to be a little provocative here. I'll just throw the statement out very quickly, but you know, the science collaborations need to take some proactive measures to get themselves up to speed. Even the early operations team, and certainly the construction team, is not well positioned to handhold everybody that needs to start interacting with, even with the early data previews. So some global coordination probably is required amongst the science collaborations.
I appreciate your point. I'm glad that you know, this will be, another person will be in charge of this. I want to say that the science collaborations, I think, have done a lot of work towards this and are working very much towards this. And you know, we also need to keep focusing on the coordination between Rubin and the science collaborations, and the participation in DP0 was certainly, and the delegates was certainly an excellent model and first step towards that.
Yeah, just to follow up on that, Chuck, we are well aware that neither operations nor construction could ever directly support the entire community, which is a strong basis for the community engagement model that we've chosen, which is to try to build up a self-sustaining community where everyone can help everyone, rather than this, you've got a question, you come to a help desk, you ask someone at Rubin, that we have a distributed network of people, a peer-to-peer network where everyone can help everyone. It's like Stack Overflow, sort of the Stack Overflow. You have a question, you ask it on the forum, and any number of people from the community could help you. And that's, I think, the only way we're really going to be able to help to get everyone in the community to a point where they can work with these data products and services.
And I think a lot of that is, in fact, directly happening in science collaborations. I know for a fact that it's happening in TVS, and I expect that it's happening in all the other ones as well.
Yeah. But maybe it would be good to get Melissa to give a talk on some point to the science collaborations about the community engagement model and how we're going to do that.
Indeed.
Okay,
we have 5 minutes left. Did you want to cover the rest?
Yeah, I tell you what I do want to go to, simply because Rachel asked questions about it. So because she asked questions, we'll go to her topic. There are 3 data facilities. You can read that. We're using an interim data facility at Google Cloud because the USDF and the operations area data facilities are not up and running yet. So at the moment, everything I've shown you, all our services are running in the cloud at Google at what we call the interim data facility. That's just a bit about DP0.1. This is what I want to show you. So based on our experiences with the Google Cloud now, we've been working with them for close on a year with DP0.1. DP0.2 will also be hosted in the cloud. We're looking at proposing a hybrid model in operations, whereby the data will be at Slack and the other data facilities. All the processing, so the data release processing, the alert production processing, all the generation of data products will be at the data facilities, but the users will be on the cloud. So the end data products will be put on the cloud, and users will have access via a cloud platform. So here you'll have a science platform deployed on the cloud with access to file stores and cloud storage behind the scenes, which will have access to the data products stored at Slack. This just shows you the telescope coming through Chile with some pre-processing data transfer to Slack. So the archive will be the USDF plus the UK and the French data facilities, and users will work via the cloud. There are many reasons for this. It allows us to separate concerns of security in terms of what we do at Slack and how we expose the end data products on the cloud. It allows us to respond better to burstiness. So when a data release comes out, you'll have seen this from every archive in the world, there's a massive great peak in users connecting, resources, downloading, etc. Cloud, be it Google or any other cloud-based facility, is very well positioned to provision resources elastically. They can elastically provide more CPU, and then they can pull it back. One of the advantages here is that let's say you as a scientist have a research grant and you have money to spend on resources that require a lot of analysis. You can use that money yourself to provision resources out of your research grant money to provision resources next to the data in the cloud and support directly your science. So it comes back to this question of 10%. We know 10% is not going to be enough. There's going to be some sort of time allocation committee, but it's perfectly envisionable that people will come with their own research grants and money to buy extra resources. And this allows you to provision those resources next to the data on the cloud and to do more analysis. So users can bring additional resources, and this, to answer Rachel's question, includes GPU. We're not planning to provide GPU at Slack or at the data facilities. That's not currently on our list of things to do. But if we go into a hybrid model in the cloud, this will open up the possibility of different types of resources that are provided through cloud services. And this just takes you to documentation tutorials that I've shown you. What's new in DP0.2? I'll just finish with this slide. So DP0.2, we are reprocessing the same data set that we served in DP0.1. So you'll be able to compare the desk process data products of version 19 of the science pipelines with what's going to come out with version 23. This will produce a fully self-consistent data release for scientists to publish on, as was the original desk processing. Additionally, we will have the force source catalogs to support time domain science. This is something that was missing in DP0.1. I think people were quite disappointed by. So we're preparing ourselves for an onslaught of the time domain community. There will be a new truth match table with the DP object table with additional truth information in it. Melissa's working quite closely with the desk on preparing this. There will be an OBS-TAP service, which allows you to retrieve images and metadata. If you're working in the notebook aspect, the best way to retrieve images is through the butler, with the example I showed. But if you're not working in the notebook aspect, the OBS-TAP service will allow you to retrieve images. And then the image cutout service based on SODA and IBA protocol will also be made available to generate and retrieve cutout images. And this is the community forum where you can go and get help. There is a category in support on Rubin Science Platform. If you have questions, please go here and ask them, because this helps us to share knowledge with the community. When we respond to a question, everyone on the platform can see it and everyone can get involved in the discussion, share their knowledge and ask their questions. So that way we create a community supported knowledge base. And I'll just end with some relevant documentation, and that's it. Thank you.
Thank you, Leanne. You finished exactly at the top of the hour. So I want to acknowledge that this is officially the end of the meeting. So if anybody needs to leave, please feel free to do so. Leanne, do you have a couple more minutes? There's a couple more questions on the chat.
I can stick around. I think I just had a meeting with Mario next, didn't I?
Thank you so much for this talk. It was really important, I think, for us to hear updates on all this. And I appreciate that you tuned it to our needs again. Meg has a question in the chat. In the interest of time, I'm just going to read it, Meg, and I wanted to go back to one of Rachel's questions. So Meg's question is, when is the decision going to be made about the hybrid model? Some folks have already started to propose NSF grants now to cover start of LSST science, and if the hybrid model goes forward, then people might want to ask for funds to buy cloud resources to support their future research and fold them into these grants. I think it's a very sensible question.
Yeah, it's a great question. when will a decision be made? That's a good question. I'm going to get back to you on that one, Meg. I'm not going to say something that might be wrong, but let me just say that both Will O'Mullane and myself, who are the DM project manager and scientist, are very supportive of this model and are pushing it. Unless you come back and say, oh no, we think that's terrible, we definitely want to access our data products at Slack, we're going ahead with it. So we're pushing it. I'm pretty confident that something like this is going to happen, but it's about, I think, convincing agencies and so forth. So maybe I'll turn that question around and ask you, Meg, when would you need a decision to support your funding requests?
When all the proposals are due.
Which is when?
So people are applying in October, November, September, right? So
this year. Okay.
I even put a proposal that if I knew that there was cloud storage, I might have asked for funding for that. Yeah. So yeah, I think it's all different times depending on where you are.
Let me point out that if a decision is made about this, it needs to be clearly stated, ideally in a citable document, because as a reminder, when we write grants for NSF, we can't put references to documents that are not cited, and there's a lot of confusion about what's funded and what's not funded under the Rubin funding model. So ideally, if the decision appears, it should be incorporated in something that has a DOI, so that we can say that this is an official statement.
Okay, so this is the same as the process we went through with the early science document last year, and I put it on Zenodo and got a DOI, and that was cited. Okay, so that's really good to know. I will take that information back to, this falls squarely in operations. This is not construction. So this is Bob Blum as Director of Operations. I will go back to Blum with this and put out the directorate's rear end.
Some questions related to that, but perhaps maybe let's circle back to it if we have time. I wanted to iterate one question that Rachel asked about single services for the RSP and like operating across astronomical services, particularly the MMA, the multi-messenger astronomy community, is discussing building an IAM system, I don't remember what it stands for, that would operate across the astronomical services. Is there any plan to support that?
Yeah, what's an IAM service?
Rachel?
Integrated identity management.
Oh, okay.
Single login.
Oh, you're talking about single sign-on, right? Okay. So we're going to have science platforms deployed at Slack, UKDF, and the French data facility, definitely. Then there's going to be a whole series of IDACs that will set up, who we hope, it's up to them, we can't force them, we're not going to run the science platform. And we'll have it running in the cloud as well. It would be wonderful if all those were integrated, you had single sign-on and you just didn't know where you went, but unfortunately that's not the case. We actually discussed this, I think I brought this up as a question at the last data facilities workshop, in fact, just recently. At the moment, if you log on to the UK data facility, the science platform, if you log on to the science platform running at, say, the UKDF, you get what's at the UK. And if you log on to the one at the French DF, you get what's at the French. They're not talking to each other. That's not going to change in the early years of the survey, but down the track, I don't know, 7, 8, 10 years in, who knows? Maybe. I wouldn't count.
And also, let me extend that a bit to bring this back to also synergy with other platforms for other kind of messengers and other kind of wavelengths, and all the work that NASA is doing and the support for the decadal service to integrate these services.
Yeah, that's true. I mean, so if you want to access data of the archives and it's small amounts of data that support analyses where you've subsetted your data, you can use the TAP service to access that data, the way I showed you with accessing Gaia. But if we're talking about large scale survey cross-match, if we're talking about cross-matching Gaia with LSST, if we're talking about cross-matching Roman data with LSST data, that is not going to happen with TAP. That you will just max out the TAP data transfer limit. And that's not the way. That requires a different approach. That requires the data centers to get together, and that requires a whole different focus, I think. I mean,
are there any
match? Sorry, just to finish. I think that there should be a sort of a given that in the the next decade, we're going to see a massive desire and for multi-survey analyses and multi-survey science. I think that there needs to be some sort of coordinated cross-survey project funded by the agencies to do exactly this and then to provide it as a service. So I'm working on LSST. I've got 1 million objects I want to get Gaia data or Roman data or Euclid data for. I go to a service that's already done the cross-match, or at least will provide me with neighbor tables so that I can run a different cross-match algorithm, which might be a bespoke or algorithm. Because cross-match is challenging.
So it's more, you're saying it's more like advocacy to the agencies to support and scope these kind of projects.
That's the approach I have.
Maybe one last question from Graham. Will the full DRP data be available through the Rubin Science Platform regardless of whether data release processing was done?
Regardless
I don't know that I understand.
Sorry, regardless of where it was done, did you say?
Yes.
Yeah.
Graham, can you?
I think
is the question.
Sorry, I was Leanne's comment about the Brits and the French not necessarily working very closely together on the data facilities kind of rung true through history, but it made me wonder whether the location of the DR processing taking place had any impact on where you need to log into to get access to a DR. It makes sense if it doesn't matter, but
no. So let's just try and separate out the processing to produce the data products with the serving of the data products to the community. We internally in the project, we are giving 25% of the processing of DRP to the UK and 50% to France, and 25% will stay at Slack. Managing that is a very challenging problem that we're working on internally, but all the data products produced and all the results of the processing will all come back to Slack. And I believe they will also, at least the catalogs all the catalogs will go to the French and the UK data facilities. I'm not sure about the images, but I can get back to you on that one. So no, if you log on to, let's see. I'm nervous about answering that question in terms of images. The catalogs, all the catalogs will be transferred. The catalogs will be merged at the end, validated as one full catalog for the full survey, and all these data centers will, the UK DF, the French DF will serve up the catalogs. The processed visit images and the co-added images, I believe, will also all be stored at the French and the UK data facility. I think I'm thinking about the raw images that might not all be transferred to each of them. But let me check that and get back to you.
all right. Thank you. Thanks for your talk, by the way.
You're welcome.
Indeed, thank you so much. And I don't see any other questions in the chat. And it's already 10 past the hour. So thank you so much for sticking a little bit longer. And also thank you for directly addressing the questions that TVS had sent, that Rachel had sent on behalf of TVS. It was really helpful for us to plan forward. And I thank everybody who came, and I will see you at the next event.
Thanks. Nice to talk to you all. Bye.
Thank you.